Welcome back. As you know, I am Eli, the computer guy, and in today's class, we're going to be doing a continuation of a previous project where we had created a little IoT HVAC system using an Arduino and a Raspberry Pi. So basically, what we're going to be doing in today's project is we are going to have our Arduino like we had before, and we are going to have an analog temperature sensor connected to this Arduino. We're also going to have a power relay connected to this Arduino, and in that power relay, we are going to plug in just a standard fan. So the cool thing about power relays in the Arduino world is essentially you just simply turn on a digital pin or turn off a digital pin. That will then send a command to the relay, and the relay will then turn on or turn off a full-fledged power outlet. And so you could plug in something like a fan, you could plug in an air conditioner unit if it's simply one of those old manual air conditioner units where you don't actually have to press the buttons. You could plug in a dehumidifier, you could plug in a water pump. Essentially, you could plug in any device that simply turns on when you give us a power and turns off when you take the power away, right? So the analog temperature sensor is connected, so we can grab what the temperature value is, and then we'll be able to send commands to the Arduino to turn the fan on or off. The Arduino is going to be connected to the Raspberry Pi using a standard USB cable, and it's going to be communicating using serial communication. Basically, what the Arduino does is the Arduino sends what the current temperature value is to the Raspberry Pi. On the Raspberry Pi, we have configured a whole interface so that then the Raspberry Pi can send a command back using the serial communication to turn on or off that power relay. On the Raspberry Pi itself, the communication between the Arduino and the Raspberry Pi, that is being dealt with using a Python script. So basically that Python script grabs the value, the temperature value coming in, and then it dumps it into a data store. It then goes to a data store, sees what value should be for the fan, so basically whether the fan should be on or off, and it then sends the command to the fan. In the past, we were using PHP, and we'll continue to use PHP in order to dynamically create a website. So basically, we have a web page that we will go to. On that web page, it will print out every 5 seconds what the current temperature value is, and then under that, there will be a little hyperlink that will allow us to turn the fan on or off. Now, previously, in the past class, when we were dealing with the data store, all we were dealing with was two simple text files. Basically, what we were doing is we were overwriting the text files, so when a temperature value came in, the Python script would grab that value, it would overwrite the old value in the text file, the PHP script would then pick up that value to print it out onto the web page. When you clicked on a link on that web page to either turn the fan on or off, essentially all that would happen is there was a text file for fan status. It would overwrite the value that was currently there, and then the Python script would be able to read that text file, see what the command was, and then send that command to the Arduino. So it's important to understand whenever you're looking at projects like this, when they start to get larger, and when you start breaking them down into their individual components, you can start deciding how you're going to build individual components based off of what your requirements were. So for our previous project, all we needed was a temperature value and to be able to send a command to the fan. So all we were using was text files, and frankly, text files worked a-okay. But what if we wanted to have some type of log file? What if we wanted to be able to see when there was a certain temperature, or what if we wanted to see what like the average temperature over a certain time frame would be? What if we want to see what the minimum temperature over a time frame, or the maximum temperature over a time frame? What if we wanted that type of information? If we wanted something like that, it would be far more useful to use a database in order to store those values. So basically, every time the Python script gets a value from the Arduino, it would then simply add a record to a table in a MySQL database. So basically with that, every time a temperature value comes in, it simply gets added to the table in the MySQL database, and then you can do queries based off of that. The same is true with the fan. So if we want to turn the fan on, or if we want to turn the fan off, one of the things we might want to do is go back and look and see what the results were of turning the fan on or turning the fan off. So when we turn the fan on, did the temperature values actually go down? Again, you could have a problem like, what if you have a fan, but for some reason it's blocked? So you turn the fan on, but it doesn't actually cool anything, right? Or let's say you have an air conditioner unit. So you turn the air conditioner unit on, but the cooling, for some reason the cooling coil had broken. So the AC is on, It's just not doing anything, right? If you could have a log file and you could correlate values, that might be something that is very useful for you. So in today's project, what we're going to be doing is for that data store, instead of using a basic text file, we are going to be using mariadb. So mariadb is a drop-in replacement for MySQL. It's what's used in the Raspberry Pi world. So we're going to be using mariadb. We're going to have two tables. One table is going to be for the temperature. So every time a temperature value comes in, basically that value is going to be recorded with a timestamp. And then for the fan, when we turn the fan on or off, every time we send a command to turn the fan on or off, that value is going to be saved within the table, and then we're also going to put a timestamp beside that. And so with this will not only allow us to be able to read the temperature value and be able to send the commands, but will also be able to give us more information. So if we want to go back, we want to do queries in the future, we want to see what averages are, maximums, minimums, that type of thing, we'll be able to do a lot more stuff with that type of information. So with that, just so you understand what's going on, let me go over and show you the example of what this project looks like when it's finished. Then we'll give you the warnings, show you how the build is, and then dive into the code. Okay, so here's what our project is going to look like when it's finished. It's a little bit messy when I try to lay it out here and show it to you in front of the camera, but if you understand what all the components are, you'll realize it's relatively simple. So right here, all we have is our standard analog temperature sensor, the standard analog temperature sensor that we always use, and this is going to be connected to our Arduino. We then have this power relay that I've shown you folks in the past. I really like this particular power relay because you can simply plug something like a fan directly into it, and this power relay, the electronic switch is on this side, and this is connected to the digital pin and the ground over on this side of the Arduino. We then have a USB cable that then runs to the Raspberry Pi, and then that's basically what we have for the Raspberry Pi. We've set up everything on the Raspberry Pi. I've installed the Apache web server, I've installed PHP, I've installed MariaDB, and the whole 9 yards. And so therefore I can go over to my demonstration computer, what I have shown up on the screen, and this is the dynamic web page that is being presented from the Raspberry Pi. So you'll notice I'm simply going to the IP address here, 192.168.1.3. I have the PHP script called temp MySQL php.php, and then how we're sending the commands is actually through get, and so we have the little get variable values up there. So this is how we're going to be getting our dynamic web page. So this is being written with PHP. It auto updates every 5 seconds, and so we can see that the current temperature value that was coming in from the Arduino is 61.53. If I put my finger on top of the temperature sensor and we wait about 5 seconds for it to update, we will see that the temperature value then spikes up to 72, and it will keep going up. Now, one of the interesting things here is, since this is in a database, we can get things such as timestamp information. So every time this updates, it shows us what the timestamp for that particular record is, and that's what we get here. This is just one of those things I'm showing you that you can pull this information out. You can use this type of thing for troubleshooting processes, the whole 9 yards. So basically this is printing out what the temperature value is and the timestamp for that particular record. Now what's cool down here is then one of the things that we can also do, since we're dealing with MySQL, is we can actually do select, we can do queries based off of information we might be interested in. So the average temperature, so this is the average temperature for all records that have been going into this particular database for a while now. So you can see the average temperature down here has been 61.66 degrees. So again, sometimes like the minimums and the maximums or what the current temperature is, that might not be of a large value. Like if you open the door, maybe the room will get warmer or maybe the room will get colder for a little bit of time, and so you might see a spike there. One of the things you might be interested in is no more. I just want to make sure on average what the temperature for this particular facility is. Then we can come down here, we can see what the minimum value is. So in all the time that this has been running, it goes through, it does a query, and it finds out the minimum value that has been detected is 55.38 degrees. So again, you know, whether you're dealing with servers or whether you're dealing with produce, this shows you whether it's getting too cold or not. Again, we can pull out the maximum value. So especially if we're dealing with a server room, we want to know the hottest it's gotten within a period of time. And so that's telling us the hottest it's gotten down here is 95 degrees. So is that within the thresholds? Then down down here, basically what we have is we have the little control for the fan. So you can see the fan is currently off. And so the first thing we have up here is a label that simply says that the fan is off. Again, remember, whenever you're designing any kind of application, you do need to give the users information so they know how to act. They don't know if the fan is on. They don't know if the fan is off. Remember, this is an IP addressable system right now. I could literally be around the world. I could be on the other side of the planet communicating with this little device if I have port forwarding set up. And so if I'm halfway around the world, I don't know if the fan is theoretically on or off. So basically, by just putting this little label here, I know, okay, the fan is currently off, and it has been off since 1448. I can see up here that the current timestamp is 1502, and so what that tells me is it has been off for at least 15 minutes at this point. So again, this is one of those that can give you a little bit of information, you know, so you know what's going on. Then down here is we have the button. So simply we have this little hyperlink that says turn fan on. So if I click on that button, it's going to take about a second, and we can now see that the fan has turned on. When it goes through the little refresh cycle again, we see this label. So it now says fan is on since, it says 15:03:18. So it says it's now been on for like 12 seconds or whatever. And then it now gives me the option to turn the fan off. So again, notice how I'm telling you the fan is on, and I'm asking if you want to turn it off. So I'm not just saying power switch. It's not just power, because that's one of the, like sometimes with these IoT devices, they just tell you power. They don't tell you whether the device is on or off. They just have a power switch. And you're like, but what is it? So by telling me that it's on, and then telling me this button will turn it off, I can click that, and then in a second or so, it should turn itself off. And so now we see that the fan has in fact turned itself off. We can see the fan is now off, and it has been off for, 5 seconds at this point. So this is what the project looks like when we're finished. Okay, so the warnings for today. The first warning that I'll give you is be very careful if you decide to use a database on a micro SD card. Remember, these types of storage are actually what is considered consumable. So basically, whenever you store data or whenever you delete data, whenever you write over data on this type of storage, that actually uses some of the lifespan of the storage, and it will shrink the amount of time that this particular storage will survive. So whenever you're going to be using a database on something like a Raspberry Pi, you really have to think about how you're going to be dealing with the storage, basically how many overwrites you want to have happen, how many deletes you want to have happen, and what is your expectancy for when you think the particular storage will fail. So when I'm showing you how to use a MariaDB, a database on the Raspberry Pi, I'm sure some people out there are losing their minds right now going, no, don't. But do remember, this is a class. I am showing you what can be done. What can be done is not necessarily what you might want to do in the real world. So again, if you're dealing with this kind of thing in the real world, honestly, if you're really dealing with this kind of thing in the real world, well, you probably what you probably want to have happen is you'd want your Raspberry Pi actually communicating with some kind of cloud database. So maybe like Aurora, or maybe use a GoDaddy account and create a MySQL database up the cloud and actually send the values up onto the internet. That might be the actual best way of doing this type of thing. If you weren't going to do that, you might want to use maybe a USB hard drive, that type of thing, because if you have a normal hard drive, it'll be able to deal with the database a lot better over a longer period of time. Or if you are going to simply be using your micro SD card, one of the things you might think about is not saving so many values to your micro SD card. So one of the things you can do to reduce the amount of writes to a database is I might put some kind of statement, a conditional statement in there of I would only write to the database if the temperature had increased or decreased by an entire degree. Right, so think about this. Like right now, literally, basically how I have this set up, every second it's updating the database. So every second it's getting a new record, which means it's hammering the hell out of that little micro SD card, which means, oh no, my micro SD card is only going to last me 6 months instead of a year. Again, this is an educational purpose. I don't really care. But one of the things I could do to try to increase the life expectancy of that micro SD card is put a conditional in there to say I only want the temperature value to be saved to the database when the temperature has increased by an entire degree or decreased by an entire degree. So right now it's a float. So if it goes up by 1/10 of a degree or down by 1/10 of a degree, it's all being recorded. But if you have it so that it will only record when the temperature value goes up by an entire degree, basically most of the time your environment should be a nice steady temperature, so therefore you should actually get very few actual inserts, additional records created, because most of the time, again, for a server room or any kind of environment, the temperature stays the same. Every once in a while you get these spikes. So that's one way that you could use a database without burning up your micro SD card. But that's one of the big warnings with this particular thing, is if you're using a database with a micro SD card, especially for production environment, think about that for a second. Just think about that for a second. The next warning for this particular class is we are using MariaDB. Maria. MariaDB. So MySQL is the database I usually show you folks how to do a lot of projects with. This is a relational database that has been around just forever at this point, 20 years, been around for my entire career. Whether you use a shared hosting plan, whether you use a Raspberry Pi, anything that you can use a MySQL database for. It's been open source, or it was completely open source. Then Oracle bought Sun Microsystems. Gets really confusing. Basically what happened is a company called Sun Microsystems bought MySQL and kept it completely open source. And then this company called Oracle then bought Sun Microsystems. A lot of people were scared of Oracle. Oh no, they had right to be. To be clear, they had right to be scared of Oracle. And so there was a fork of MySQL called MariaDB. The important thing to understand about MariaDB is what is considered a drop-in replacement for MySQL. So literally the only difference for installing MariaDB or dealing with MariaDB, generally until you get to the really high stuff, is that when you do the command, when you do the apt-get install, basically you'll be asking for MariaDB instead of MySQL. So you ask for MariaDB, that will install MariaDB onto your Raspberry Pi. From there, it's basically more or less identical to MySQL, but it is just important that you remember you are going to be installing MariaDB and not MySQL. So that would be one of the other warnings there. Beyond that, again, we just got a lot of low-level concepts that we're dealing with, but it is a wide area of knowledge you have to understand. We're going to be dealing with the Arduino, the Raspberry Pi, Python, PHP, CSS, HTML, MySQL. So everything that I'm going to be showing you is relatively low-level within all of those subjects, but you do have to have a basic understanding of all of those subjects in order to get this particular project to work today. So with that, let's go over to the workbench. I will just show you how this project was built. Then I will show you the Arduino code. Then we'll go over to the Raspberry Pi. I'll show you all of the commands in order to set up this particular server. Then I will show you the Python and the PHP code. Okay, so let's take a second and look at the physical build for this particular project. Again, we're starting with our standard Arduino Uno, the same Arduino board that we normally use. On this side over here, we have our analog temperature sensor set up the exact same way we always do. The power is connected to the 5 volt, the ground is connected to the ground, and the sensor pin goes to A0 on the Arduino. Then we have this particular power relay. I really like this power relay, digitalloggers.com. I don't make any money for telling you this. It'll cost you about $25 on Amazon, but what's really great about this is it's all completely built. You don't have to worry about accidentally electrocuting yourself if you do something stupid while you're using it. Basically, it's as well built as just a standard little surge protector or whatever. The addition that it has for you is the little on-off switch that you can connect to your Arduino on the side. So I have my fan here. My fan, the power position on the back is set to on. And then I have this plugged into the relay for normally off. So normally it'll be off, the fan will normally be off, but then when I get the signal to turn the fan on or turn the power outlet on, it will turn the power outlet on. From there, basically ground simply goes to ground on this side of the Arduino, and then for the digital pin, we are going to digital pin 8, and that is the basic setup for this component here. Then from there, I have this all just the USB cable that then connects us to our Raspberry Pi. And for the Raspberry Pi, I have this hardwire connected into my network just to make it easier for networking issues. And that is the basic setup and the basic build for this particular project. So with that, let's go over and take a look at the Arduino code. So this is a sketch for the Arduino, and it's the same sketch, honestly, we've been using for a couple of projects now. Again, that's an important thing to realize when you start building larger, more complex projects, is that you can essentially widgetize a lot of the things within that project and then reuse what you have created in the past, right? So the Arduino doesn't care what the data store is on the Raspberry Pi, whether the Raspberry Pi stores the values in text files, in a database, stores it up on the cloud, all of that type of thing. The important thing to realize is that the Arduino doesn't care. All the Arduino has to do is it has to send the values to the Raspberry Pi, and then when a command is, it has to interpret those commands and then do something based off of those commands. So we have the exact same sketch we've used for a number of different projects here, because as far as the Arduino is concerned, the data store does not matter. One of those things just to realize with these projects, and it can make a lot of projects nicer when you realize that you can reuse so much, and you're like, oh, okay, I don't really have to mess with the Arduino. I don't have to mess with a lot of things I've already built in the past. I only have to reconfigure a couple of things. So anyways, when we take a look at this particular sketch, again, it's pretty simple. First thing that we're going to do is we're going to create a variable called command, and that is going to be a string. So that command is going to be interpreted down here, and it's going to be on or off or else. So basically when the command comes in and it's on, it'll basically turn the fan on. If the command comes in and it's off, it'll turn the fan off. If it's else, it'll turn the fan on for half a second, and then it'll turn the fan off again. Basically that kind of gives you an error code. So what we're doing here is we're just creating the variable command. Then we have to define the two pins. So we have an analog pin. So sensor pin is going to go to A0. Fan pin is going to go to digital pin 8. We're then going to set everything up. Again, do remember to start the serial communication. Serial.begin at 9600. Again, this speed can be different, but it has to be the same in both the Arduino and the Raspberry Pi. I would highly recommend you leave it at 9600. Pin mode for fan. Since fan is a digital pin, we have to set it to output. So it's actually sending a command out. Past that, we're then going to go into the loop. This is the same copy-paste formula we use for all projects. And again, this is one of the things that can get coders really screwed up, is so many times we just copy and paste this stuff, right? So if you make a little error, or if there's a little edit and you don't realize that it happened, you might copy and paste the same code to many different projects and have problems with many different projects. So even though you're copy pasting, it is important just to go through and just make sure it looks how you think it's supposed to look. But basically what this does is it takes the value from the analog temperature sensor and then turns that value into temperatures, right? So basically we're going to get a temperature C for temperature Celsius, and then we're going to get a temperature F, and that's going to be for the temperature Fahrenheit. So the temperature Fahrenheit is what we're going to be sending to the Raspberry Pi. Then we're going to go down here, serial.println temperature F. So this is serial printing out, so serial communication. This will go up to the Raspberry Pi so the Raspberry Pi can do something with the value. So it is saying, look, here's the value, do something with it. Then we're going to go down here, and this is where it starts listening for the serial communication back. So it sends out a command, and then it's going to listen for the communication back in. So if serial is available, so if there's serial communication, command is going to equal serial.readString until /n. So basically it's going to read the value coming in until that /next line, and it's going to take that value. Command.trim, so what this does is it trims out any additional white space, especially when you're tossing around values for communication. White space can screw you up. Remember, on with a space at the end is different than on without a space. So when you do conditionals, if command equals on is ON, and what it's receiving is on with a space at the end, those two things do not equal. So what we're doing is we're trimming out the white space so we don't get any kind of those stupid errors. Then all it is here is if command dot equals on. So if the command is on, digital right, fan pin high. so I turn the fan pin on. Else if command is off, so the command is off, digital write, fan low, so turn the fan off. Else, and again, whenever you're writing this code, it's very important to think about like little troubleshooting routines you can put in there. So it should almost always be on and off. It should almost always be on or off. But what if you forget about the trim? Or what if you do something stupid when you're querying the MySQL database and you grab some information that you weren't supposed to get, right? And then that is being sent to the Arduino? By having an else, so if it's not on, it's not off, it's some other garbage, then what this does is it digital write, so it turns the fan on, again, for half a second. So it turns it on, delays for half a second, and then turns it off. This is a way to kind of give you an error code for this project if for some reason the Arduino is getting some garbage commands. Then past that, we're going to come out and then we're going to delay for 1,000 milliseconds. So this will simply delay for 1 second and then it will loop through. So that is one of the delays here when I was talking about the database and, you know, not writing too much to the database. Here is where I have a little delay. So theoretically, this could run a lot faster. This could be hitting the Raspberry Pi and writing to the database much faster than it is, but this is a way I can delay it for at least 1 second so I don't get too many records in that Maria database. But this is what the Arduino looks like. So let's go over and take a look at how to build the actual Raspberry Pi server. I'll run you through the commands for that, and then we'll show you the Python and the PHP script. So here we are at my Raspberry Pi. I've typed out all the commands for how you create this server because at this point it gets a little too complicated to actually type everything out, but I will run you through the process. So initially what you do is you use a Raspberry Pi imager in order to create the OS image. You use that to boot up your Raspberry Pi, and then you go through the standard setup procedures. Once you have done that, you will then need to go to the command prompt, and you're going to need to type in a lot of commands. So the first thing that we're going to do is we're going to type in the command sudo apt update. So what sudo apt update will do is this will go out and it will actually update all the information about the repositories so where all the different pieces of software and all that are kept on the internet. That is what is done from this command. Then we're going to do sudo apt get upgrade. And so what upgrade will do is make sure that our Raspberry Pi is updated to the latest version, you know, latest patches and all of that type of thing. The next thing that we're going to do is we need to turn this into a web server. So we're going to do sudo apt-get install Apache 2. So that's going to install the Apache 2 web server. Then what we're going to do is we need to change the ownership of the HTML folder to Pi. So Pi is the default user for Raspberry Pi. So whatever your user you're using, plug that in here. And what we're going to do is we're going to change the owner of /var/www/html to be Pi. What that allows us to do, it allows us to easily go into that HTML folder and be able to read and write scripts without running into weird permission issues. Then we're going to go down, we're going to install PHP, so sudo apt-get install PHP. Then what we're going to do is we're going to install mariadb server. So this is one of the quirks if you're used to creating a LAMP server. Normally you install MySQL at this point. Again, mariadb is a drop-in replacement for MySQL. So we're going to be installing mariadb instead. So sudo apt-get install mariadb. Then past that, we actually need to then install the connectors. So when you're going to be using any kind of programming language to communicate with a database, there are connectors, pieces of software that allow that language to communicate with the database. And so we need to install that for both PHP and for Python. For PHP, we're going to stay at the command line. We're simply going to do sudo apt-get install php-mysql. So this will install the MySQL connector for PHP, so PHP can communicate with MariaDB. Again, an important thing to understand here is you see how that's MySQL. It doesn't say MariaDB. Remember, MariaDB is a drop-in replacement for MySQL, so all the tools created for MySQL will work with MariaDB. Then past that, we need to install the connector for Python. I think the easiest way to do this is actually through Thonny, since we're using Thonny for most of our projects anyway here. With Thonny, what you can do is you can go to Tools, you go to Manage Packages. Let me stop here. Let me stop it. So stop, Tools, Manage Packages. Then from here, what you can do is you can do MySQL connector, and then you do search on PyPy, and then you click on this, and then you would click install to be able to install that. So that is what you're going to want to install for the MySQL connector for Python there, and that will have everything run for you. Then what you're going to do is you're going to then go into your MySQL database. So you're going to do sudo MySQL. So again, even though it's mariadb, with sudo MySQL, it'll get you into the database. Then you're going to create a database for the temp app. So you're going to create the temp app database. Then you're going to use temp apps. You're going to go into that database. Then you're going to create a table for temp. The first thing you're going to do is you're going to create a temp ID. So just a standard temp ID primary key type thing. It's going to be an int. It's going to auto increment. It's going to be your primary key. Then you're going to have the temp, the temperature value. That is going to be a float. Then finally, what you're going to do is you're going to do a timestamp, not null, default, current timestamp. So what this does is this creates a timestamp within MySQL. So whenever you're doing something like creating a timestamp for a database, that timestamp can come from a number of places. It could theoretically come from the Arduino. It could come from the Python script, or it can simply be done within MySQL. So with this, I'm figuring the simplest way of doing this is actually doing it within MySQL. Then we're going to come down here, create table fan status. So this will be the table for fan status. Again, status ID, that's going to be a primary key. Then status text, so this will be text because it will be on or off. Then timestamp, not null, default, current timestamp. So basically, whenever we turn the fan on or off, we're going to get that timestamp. Then you're going to come down here and you're going to create a user to actually be able to use this particular database and these tables. So you're going to create user, temp user, identified by 1, 2, 3, 4, 5, 6. And then we're going to grant all privileges on temp.star. So basically all the tables within the temp app database to temp user. And so that will create the database for us. When we go over, we can then actually take a look at the database. And so one of the things you'll notice here is I did not secure the installation for the MySQL or the MariaDB. So when you install MariaDB or MySQL, there is a security routine you can go through, and that'll make sure that the root user password isn't empty. It cleans out a lot of things. It makes it secure. You will notice with this particular project, I did not do that because I think that's overkill, again, for simply showing you how this stuff works. If you know how to secure your MySQL or MariaDB database, by all means, please do. I just left that out of this particular project just to make things a little bit easier. So what we can do here is we can do sudo, and we can just simply go into MySQL. Again, remember, whenever you're using commands, you can simply use MySQL instead of MariaDB since it's a drop-in. And now we're actually in the MariaDB. From here, I can do show databases. And it shows us what the databases are. The database that I care about today is temp app. So we can use temp app. We drop in, and then we can do show tables. Then here we can see we have the fan status table and we have the temp table. If we do describe fan status, it'll show us we've got the status ID is an int, primary key, auto increment, status is a text, and that's the for on or off, and then we have the timestamp. If we do describe temp, it gives us the same type of thing. Again, temp ID, temperature is a float, and then we have the timestamp. Then the cool thing is, and again, what makes this interesting now that we're using a database, is we can do select all from temp. So we're selecting all the records, all the columns from the temp database. And if I click, there are a lot of records at this point, but see what's happening here is you can see these are the record values over here on the left, these are the temperature values, and these are the timestamp values. So now I have all of these values, basically since I turned this project on, that have been recorded, and they're recorded now with a timestamp. So if I wanted to go in, I wanted to do select statements based off of certain time periods. You know, what is the average temperature at noon? Right? What is the average temperature at night? What is the average temperature on Tuesdays, right? Theoretically, you could go in and you could actually create a MySQL statement to actually find that information since that's there. Then, as far as like a log file is concerned for your fan, if we do select all from fan status, basically you have the same type of thing here where you have the ID. So this is the ID for when you turn the fan on or off. So this is the command that was given, and then this gives us the time code. So again, you could do SQL queries based off of how often is the fan turned on or off, you know, different types of things. So now you don't simply have a text file where it doesn't give you a lot of additional information. Now that you have a database, you can start trying to pull some additional intelligence out of what is occurring. So with that, let's go over and take a look at the Python script. So we're going to be using Thonny like we normally do. And this is our Python script. It looks a lot like what we've been using in the past. The difference is going to be the SQL statements here. So up at the top, what we're going to do is we're going to import MySQL.connector, and then we're going to import serial. So these are the two modules we need, serial communication and the MySQL communication. Then what we're going to do here is a standard thing we've been doing this entire time for many of these projects is we're simply connecting to the serial communication and TTY-ACM0. So do remember this may iterate up or down when you plug in and unplug your Arduino. So if for some reason it doesn't work, just go here and if it's 0, make it 1. If it's 1, make it 0, and that'll most likely fix your problem, at least as far as serial communication is concerned. Then we're going to come down here and we are going to create the configuration information to connect to the MySQL database, so the Maria database. So mydb equals MySQL .connector.connect, and the host is localhost, the user is temp user, password is 123456, database is temp app. Now again, notice with this information, I could plug in an IP address here. So if I could connect to a remote MySQL server, I could simply connect that in here, and I could be sending these values and receiving commands, again, also from anywhere in the world. You know, I could have a server in China, and I could send temperature values to China and have my fan get turned on or off from a server in China, right? Really, remember, this is on the internet. It doesn't really matter. But again, for our particular project today, we're using the local host. My cursor equals mydb.cursor. So when we actually start trying to do things with the MySQL database, we're going to be using the variable called myCursor. Then we're going to come down here. So while true, if serial and waiting is greater than 0. So basically, if there's communication coming in from the Arduino. So line, so we're going to create a variable called line, and that's going to equal the serial.readLine. So the line that's coming in, we're going to decode it to UTF-8, and then we're going to strip out anything at the end. So our strip basically strips out any white space. Again, remember we need to strip out any of that kind of white space. And so that's the value coming in from that serial communication. Then what we're going to do here is we have a variable called temp. So we create a variable called temp, and that is going to equal line, this line value. When this value gets created, this is actually a string. And remember, when you're dealing with a programming language, is you can't add a string to an int. You can't add a string to a float, right? A string is text, and a float is a decimal point number, or an int is just a normal number. So one of the things you can run into is if you have a number, but it's a string data type, things can fail out. So what we're going to do is we're going to take a line, we're going to turn it into float. So basically what this function does is it turns whatever you put into it into a float or whatever. So you do int or whatever, and that is going to be assigned to temp. So temp is now going to be float. It is now going to be the float of whatever came in. SQL is then going to look like this. So what we do here is this is our standard SQL statement. So insert into temp, so the temperature table, the temp column, right? Values, and then we do this little %s. So with a %s, what we can do is right outside a SQL statement, we can say %time, and then we can feed it what the variable is. So we have this float variable that we've created. So what will happen is this variable will then basically automatically get put in here. So whatever this value is, that is what gets assigned here. And so when that dynamically changes, that will dynamically get put into the database. So insert into the temperature table, the temperature column, the value of S, which comes from temp. So again, %temp, and that goes in here. Then what we're going to do is myCursor.execute SQL. So this here, so basically we're going to be executing the SQL statement, and then mydb.commit, so we're actually committing that execution, and so now that value will be saved into the MySQL database. Then what we're going to be doing is we're going to be reading from the database to look for commands based off of fan status. So for this, myCursor.execute, we're going to then execute select status from fan status, order by timestamp descending limit 1. So basically what this is going to do is this is going to select status. So it's going to select from the status column from the fan status table. We are going to order by that timestamp that we created descending. So basically this means the latest. So the latest timestamp will be first, and then we're going to limit it by 1. So what we're doing here is we're essentially grabbing what the last record is from fan status. Then fan status equals myCursor.fetchAll. So basically what it's going to do is it's going to grab that, basically it's going to go out there and it's going to grab the values from that SQL statement that you just ran. And then what we're going to do with this is we're going to go to fan status. So fan status, what this here becomes what's called a tuple. So a tuple, and normally in like the programming languages, there are arrays. So an array is generally how you normally store multiple values within a variable. So, 1, 2, 3, 4, Bob, Sue, Bob, whatever. In Python, they have what's called a tuple. So basically, when this executes, and we fetch that information here, that'll be stored as a fan status. It will be a tuple. So the tuple is not a normal float or normal int, so we actually have to grab the value from that tuple. So what we're going to do here is we're then going to have fan status again, and fan status is going to equal, this is how we look at the first space in the first basically category that comes in from that tuple. So you can have a multi-layer tuple. So we're going to say from the first layer of the tuple, 0, the first record from that layer. So at the 0, 0 position, that will be either on or it'll be off as long as our code is working properly. So we're going to select status from fan status, order by timestamp, descending limit 1. So that will go to the mariadb database. It will look in the fan status table. It will look at the status column. It will grab whatever value is in that status column. It is going to return that as a tuple here. And then so what we're going to do is in the 0 position, in the 0 index of the 0 position, we're going to have that be fan status. And then we're going to do if-else statements here. So if fan status equals on, so if the value coming in from that database is on, then serial.write b, so this is how we encode what we're going to be sending back through the serial communication, on/n. So basically what we're doing is we're sending this command, and that gets delineated on the Arduino by the /n. If fan status equals off, then serial write, ser write, b off. Right? Else, ser write, b error /n, and then print error out down here. Right? So basically, if for some reason there is an error, it will then get printed out on the screen. And so this is one of those things you can do for that troubleshooting routine. Remember, in the Arduino sketch, if it's on, it turns the fan on. If it's off, it turns the fan off. If it's anything else, right, it'll turn the fan off for on for half a second and then turn it off. So if you send error, if you serial write error to the Arduino, the fan will turn on for half a second and then turn off, and you know there's a problem. Then again, print error. So print error if there is a problem with this kind of thing. And then for just standard troubleshooting procedure down here, we have print, temp. So the value for the temperature value, and so that is here. And then we do inserted, so that record is inserted. Then you have fan status is, and then we grab whatever the value of fan status, so what we created up here, and so it's currently off. So basically, if I start this again, it'll turn on, and so it shows, okay, 58.89 inserted, fan status is off. If I touch a little temperature sensor, it'll show the temperature is going off, the fan status is still off. If I go over to my little website and I turn the fan on, so I just turned a fan on, so you probably heard it click on, so now it says, 6593, fan status is on. So I have all of this as a little troubleshooting routine to try to understand what the Python script is actually seeing. So now I turn the fan off and we can see the fan off. So this is what the Python looks like. So with that, let's go over and take a look at the PHP. Okay, so here we are at the PHP script. So basically with this PHP script, the first thing that we have done is at the top, I have simply created the HTML auto refresh that we use for a lot of our projects. So the meta HTTP equiv refresh content every 5. So basically every 5 seconds, the web page will automatically refresh itself. I like using this instead of JavaScript or anything just because it's a little simpler for these types of projects. The next thing we're going to do down here is we're going to put a title for the page. So h1's style equals text align center, database temp app, and you're going to close the h1. You will notice this is outside of the PHP script, so you can just write your normal HTML here. And if we take a look at our web page, basically this is simply that title that we have going on there. Then what we're going to do is we're going to go down and we are going to open up the actual PHP script itself. The first thing that we're going to do is we are going to have the fan status update. So an important thing to understand about this particular project when we're dealing with a PHP is that the PHP script is doing a number of things. One, it is dynamically grabbing the values from the MySQL database, the mariadb database, in order to give the temperature value, but it's actually also an HTML form where we're using get in order to send values to itself, right? So basically here, if you look up at the top, you can see fan status equals off. So that we're grabbing that value and we're going to be using that value later in this particular project. If I go down here and I click on this link to turn fan on, so I click that on, we should hear the fan click on in a second. And then wait one more second and it'll be say fan is on. So what we can see up here is we can say fan status equals on. So what I'm doing is I'm using this hyperlink, and this hyperlink basically has this in the hyperlink in order to turn the fan on or off. We're grabbing that value. So that's what's happening with the get up at the top of this particular page. So basically fan status is going to equal the get value coming in from fan status. That is the hyperlink all the way down here. So basically we have this href, mytemp, MySQL, php.php, fan status equals off. So, or fan status equals on. So these values, that's the link down here at the bottom of the page, right? So that's what's happening. That's one thing whenever you're looking at PHP script like this, you may have to go up and back and around just to make sure you understand what's going on. Then past that, we're going to have the information for connecting to the MySQL database. So server name is going to equal localhost, username is temp user, password is 12356, database is temp app. Again, you'll notice these are just simple configurations. So if you had a cloud-based, MySQL or MariaDB server, you could simply connect using the information here. It's local in this particular project, but again, if you wanted to use a GoDaddy account or an Aurora account or something like that, you could. Then we're going to go down here. We're basically going to create the MySQL connection. So $con is going to equal a new MySQL I. So this is the connection information, server name, username, password, and database. And then we're going to say is if there's a connection error. So for that con that we're creating, if there's a connection error, it's going to print out on the screen, connection failed, and what that connection error is. Hopefully you don't have a problem. Then we're going to go down here and we're going to go create the actual SQL statement itself for the temperature value, right? So when we're taking a look at the page, what we're dealing with right now is getting the information for this particular temperature value. And so what we're going to do is select all from temp, so it's the temp table, order by timestamp, descend, limit 1. So basically DESC, this will give us the latest, the most current timestamp first, and then we want to limit the results by 1 because we only want whatever the latest timestamp is. So we only want what the latest result is. So select all from temp, order by timestamp, descending, limit 1. Then result is going to equal the connection query, and we're going to feed it that SQL variable that we gave it. So it's going to then send the SQL statement. It's going to actually do the connection, the query, and that's going to go to result. So if, $result, number of rows is greater than 0, we're going to go through and we're going to grab the information. So while $row equals result fetch association, we are then going to print out, the temperature value, and we're going to print out the timestamp for the temperature value. So it prints out the temperature value, and we're also printing out the timestamp of that temperature value right down there. So with this, it's print, it's style, text align equals center for both of them. For the temperature, we want it at 200 pixels. For the timestamp, we want it at 50 pixels. Top margin for both is 10 pixels. Bottom margin for both is 10 pixels. And then all we're going to do over here is we're going to then concatenate in. So we close the double quotation marks, then we do period, $row, and then the temp, the temp array right there, the value for temp in the array. And so that is going to give us the temperature value. And then $row, the timestamp, so that is going to give us the timestamp value. So this is the column name. So if it's temp as the column name, whatever your column name is, that is what you would put here. And then timestamp, that is what you put there. And that is then what prints this out on the page. So it is centered. This is 200 pixels. This is 50 pixels. This is the current value for the temperature, and this is the current value for the timestamp. So that is what is happening there. Then what we're going to do is we're going to go down and we're going to create the next block. So we also, I'm sorry, right here we also have the else. So if there's a problem with the temperature table, it'll just say temp table is empty. So hopefully you shouldn't get that, but again, another little troubleshooting routine there. Then we're going to go down and we're going to deal with the next block on the page. So if we go here and we take a look at the next block, we can see what we have an average temperature, we have a minimum temperature, and we have a maximum temperature. So again, we start getting to play with the values in the database a little bit. So that's what we're going to print out here. So we're going to have a $SQL AVG is going to equal select and then min temp. So the minimum temperature value in the temp table as min temp. So we're now going to access that as min temp. Max, so whatever the max value in the temp column is, we're going to have that as max temp. Then AVG, so the average temp as AVG temp from the temp table. So what this is going to be doing here is it's going to ask us what the minimum value in the temp column is, what the maximum value in the temp column is, and what the average value of all of those values in the temp column is out of the temp table. And then we're going to be giving that a new name. So AVG temp for the average, max temp for the max temp, and min temp for the min temp. We're then going to do the whole connection again. So AVG temp equals connection query, SQL AVG. So that's going to go through. We're then going to do AVG result equals AVG temp fetch association. And then we're going to go through and we are going to print. So basically this is going to create our division. So we're going to create that box. So when we take a look at this box right here, so we're creating this box. And so creating that box, we're going to have a border of 1 pixel. It's got to be solid black. The width of the box is going to be 300 pixels. Margin left is auto, margin right is auto, so that's going to center it. Padding is 10 pixels. So basically, if you take a look at this, what that means is it's 300 pixels, it's centered in the middle, and then you have a padding of 10 pixels, so that kind of centers all of the text in the middle there. Then we're going to go back and we're just simply going to print out the information that we want. So the average temperature, so in simple text, we're going to say average temperature, and then we're going to say $AVG result and AVG temp. So we're going to print out what AVG temp is, that value here, right? Then we're going to do minimum, we're going to break the minimum temperature, and then we're going to do AVG result, what the min temp is. So that's what we have here. And then we'll do maximum temp equals, basically we're going to print out AVG result, maximum temp. So the max temp that we got up here. And then if we look at our page, that is what we're dealing with right there. Then we're going to go down and we're going to deal with our little fan switch. And so basically with this, we're going to have another SQL statement again. For this, I did just a $SQL again, equals select all from fan status, order by timestamp, descending, limit 1. So basically what this is going to do is it's going to go to that temperature or the fan status table. It's going to pick out what the last change to the fan status table is, and then we're going to be able to do if-else statements based off of that value. Result is then going to equal connection query. So basically, we're going to query that. We're going to come down here. We're then going to print out, again, that div again. So we're going to print out the box. So this box that we're creating here, we're going to be printing out. Again, solid black line with 300 pixels, so on and so forth. So if result, number of rows is greater than 0, while result fetch association. And then what we're going to do here is fan status equals row status. So basically we're going into that fan status table, and we're going to grab out the value for the fan status table. And then fan stamp equals row, whatever the timestamp is there. Then what we're going to do is if fan status does not equal fan status update, then we're going to do something, right? So the fan status update, that is here. So this is one of those things. I put a limiter in here. So I only want to update the table when the new command is different than the command that has already been put in. So remember, this page auto refreshes itself every 5 seconds. So what that means is this command also auto refreshes itself every 5 seconds. So a problem that you can run into is if you don't put any kind of limiter in there, it'll simply every 5 seconds, every time this thing reloads, it will basically then rewrite something. It'll write a new record to your fan status table, and that can cause you a problem. So what I want to do is I want to say only if this value here is different than what the last value is in the table do I want to rewrite to that table. If you don't do that, you get a weird little error where basically the fan keeps like turning itself on and off. It's a bit of a pain in the butt. So basically what we're saying here is, so if the fan status does not equal, so the value that we pulled out of the database, if that does not equal the fan status update, the value that came in through the get, then SQL fan status equals insert into fan status values, so basically the value, the fan status update. Right? So basically if the current fan status is off, and the fan status update is on, those don't equal, and so then we're going to insert into fan status that new value. If the current fan status is on and the fan status update is on, it will fail out because there's nothing there to do because it will fail out. So if the connection query fan status equals false, so if this fails, echo get error, else echo fan status log is empty. So basically, for some reason, the fan status log is empty. This will get printed out that you have an error there. Then we're going to go down, and then we're going to actually get into printing out the actual commands down here. Basically, the fan is off or the fan is on. When we take a look at this, basically, if fan status equals on, then print fan is on since whatever the value of fan stamp is. Then print the ahref, so basically print a link that says ahref equals temp MySQL php.php. So basically this loops back onto this particular script, and we're going to say fan status equals off. So if the fan is on, it's going to say the fan is on, and then the link is going to be to turn the fan off, and it'll say turn the fan off. Else if fan status is off, then it'll say print fan is off since the timestamp, and then print with that ahref, basically looping back on itself with a fan status is on. So this will be the link to turn it on. So what this does is basically when the fan is off, you get a link to turn the fan on. When I click on this and I turn the fan on, give it a second with how this thing works. Oh, and then we can see on, and then it gives us a link to turn the fan off. So basically, this is how we dynamically create that notification to the end user, and then we dynamically create the switch so that we can turn the fan on or off. Else, so if it's on, do this. Else if it's off, do this. Else. So this is important when this is brand new, when you have not added anything to your table yet. So basically when you have not actually turned the fan on or off before, right? Then it'll be an empty value. When you do the SQL statement, instead of getting on or instead of getting off, you'll get an empty value. So what I'm doing here is a little bit of an error control thing. So I'm going to print out, fan control error. So essentially, if the table is blank or if there's some other problem. And then what I'm simply going to do here is print ahref equals, and then I'm looping back to this particular page again with a fan status of off. So I don't want to screw with the fan. I don't want to turn the fan off or on if I don't need to turn the fan on. So basically all this is going to do is it's just going to send this off command to this script. So then it will create the first value within that fan status table. The what will actually print out on the screen as far as the href is concerned, the hyperlink is it'll simply say reset fan communication. And so what will happen is when you click on this, it will send the off command to the page. The page will then be able to read that off command. It will then store that off command into the table. Once you have stored something into the table, then it can then give you that it's been off for a certain amount of time, so on and so forth. Then we're going to do print the div. So basically we're going to close that div, that box that we created, and then we are going to close the connection. And so basically this is what we have going on here. And, you know, it's a bit of code, one of those things to go through and take a look at in the actual description at the site, at our actual website. Go through, take a look at the code, take a look at the PHP code, take a look at the Python code, take a look at the MySQL. And I think if you take a look at a lot of it, it'll make a lot more sense. But that is a simple walkthrough of what I did for this particular project. And so with that, with that particular project, again, as I say, you get this nice dynamically created little web page here. It shows you what the temperature is. The temperature goes up. When the temperature goes up, automatically updates. Hopefully, yep, it automatically updates, and then I can turn on the fan. Turn the fan on. And then wait a couple of seconds, wait a second, and then I can turn the fan off. And it turns off. And again, on top of being able to get the temperature value and all that, I can also then get the average value, the minimum temp, and the maximum temp. And so that's basically how this particular project works. So there you go. Now we've created our little Arduino, a Raspberry Pi IoT HVAC system, and we've used a MariaDB or a MySQL DB as the data store for the temperature values and for a logging system for when we turn the fan on or off. Again, why this is useful is because now you can start doing queries, you can start creating things like reports. So if you wanted to do charts, so if you wanted to show when the temperature in a facility went up and when the temperature in a facility went down, if you wanted to correlate that to when a fan got turned on or a fan got turned off, you can now start creating some more interesting things. Again, when you're simply using a text file as a data store, basically, what I showed you before is we only have whatever the latest value is. When I turn the fan on, it shows you that the fan is on. When I turn off, it shows you the fan is off. Whatever the last temperature reading is, it shows you what that last temperature reading is, but that's it. You cannot easily be able to get what the average temperature is. You can't easily get the minimum or the maximum temperature. You can't easily create a log file or some kind of dashboard system based off of using that type of text file. Once you start using a database engine of some sort, you can start to do a lot more interesting things. And then again, now that you have that information in a database, then other coders could then be able to connect into your database. Again, since it's a MySQL database, you can create user accounts. So you could have other coders, you could give them different permissions for that particular database. And so if they wanted to create their own dashboards to show their own specific information, they might be able to do that type of thing. So imagine if you had an HVAC system like this. But you had it for you had the same type of system for, let's say, 50 different facilities. Now, let's say those 50 different facilities, every 10 facilities has a different IT person that's responsible for those facilities. Each one of those IT people, they always do what they want. They always want to do things unique. They always have their own perfect way of doing things, right? So if they're going to create a dashboard, if they're going to create alerts, they may be worried about specific things. And so basically what you can do, if you have all of this information getting dumped into a database, then you can give those different system administrators different permissions into your database here so they could pull out values, and then they could determine, okay, so I want these particular values, I want certain events to trigger based off of certain things, and they could all come up with their own, basically, the pane of glass, basically something that they're looking at that would give them the best amount of information. That's the type of thing that gets really interesting when you start using databases. Not only that, but again, as I talked talked about, you could have 50 different devices all pumping into like one database. And so again, if you're a CIO, if you're a CTO, you can start getting a much richer view of what is going on with your environment. You can have all your HVAC systems pumping data into that database. You could have your people tracking, your employee tracking systems pumping information into that database. So you can notice, like, let's say the air conditioner turns on at 6 o'clock in the morning, but if you have that connected to a system that tracks like motion in a building, what you might notice is that the air conditioner clicks on at 6 o'clock in the morning, the temperature comes down, but nobody walks in the facility until 9 o'clock in the morning. So think about this. If you have 50 facilities, and that's the case in all of them, then you might not want the air conditioner to turn on until 8 o'clock. Having an air conditioner run 2 additional hours for 50 facilities, day in, day out, that may cost a lot of money. So if you can look and you can say, okay, I know that people don't come into this facility until 9 o'clock in the morning because I can actually track that using my little device that's collecting motion information, and I know that currently the HVAC system clicks on at 6 o'clock in the morning, then what I want to have happen is I want to push that up. Let's turn the HVAC system on at 8 o'clock in the morning so that we're not heating or cooling basically an empty building for 2 hours. Not simply one empty building, but let's say 50 empty buildings for 2 hours. Also, if you have all this connected, again, let's say you have that motion sensor system connected in this whole database system. If one office for some reason, maybe they're under a crunch, like most offices, people aren't coming in until 9 o'clock in the morning, but you have one office where people are coming at 5 o'clock in the morning. So they're coming at 5 o'clock in the morning. The facility is hot or cold because the HVAC system hasn't turned on. If you have a motion detector, that is pumping information into the database. You as a CIO can see, oh, people are now coming to this site, this facility at 5 o'clock in the morning. Okay, for that facility, let's turn on the HVAC at 4 o'clock in the morning so the temperature is regulated by the time people come in. Once you have these IoT devices, and these IoT devices then start pumping the information into a database, you can start doing a lot of really interesting, really cool things with correlations and creating dashboards and all that kind of stuff. And then from there, it really is sky's the limit. It really can start to be really fun and interesting. So this is just a little project here just to kind of show you how all of this kind of stuff can work. Again, go play with it, screw around with the code. I'm not the greatest coder in the world. Again, for any old timers, I'm not the greatest coder in the world. I'm showing you how this works. I'm showing you what you can do. I'm showing you what you can do. So by all means, go in, edit the code, modify the code, the whole 9 yards, and then think about how you can make it better and more useful for your particular environment. Again, the only warnings for this particular project is do be careful about running a database off of one of these little micro SD cards, because this is considered a consumable form of storage. Basically, the more you erase blocks or you overwrite blocks in this type of storage, the less lifespan it will have. So reading's fine. It can read all at once. It'll read for eternity. But every time it overwrites, or basically it deletes or overwrites a block, that actually degrades the storage itself. And so if you have something like a database continually hammering a micro SD card, I don't know. I'm not sure when it will fail. But it definitely won't get what you would consider the full lifespan out of it. So just be careful with that. That's kind of thing to think about. It's not that you can't do it. It's not that you can't do it, but you might want to put some type of limiter in there. Again, only when the temperature goes up or down by a full degree, then will you write to the database. Put in some type of limiting factor like that. That's something that you might want to think about with this type of project, using a database on a micro SD card. But other than that, go play with it. Remember, you're using MariaDB when you're using a Raspberry Pi, and see what fun you can have. So as always, I enjoy this class and look forward to showing you the next one.